Welcome to Season 2, Episode 8. This one gives us a velocity formula in meters per second, and it starts asking us about distance travel. And distance, right, we need to know, it's the total movement, as opposed to displacement, which is also asked later in this question, which is just how far you've moved relative to an earlier position. So that's, if I walk to the door and back, straight back to my chair, my displacement's 0, but my distance would be about, 8 meters. So different terms, and you have to be very careful with that. So earlier position. Alright, so in this case, question A is asking us the distance travelled from t is 3 to t is 5. Because it's distance, I'm going to be very careful from the start. I need to check where this function, oops, I wrote it down incorrectly. It's t squared take 3t. I'm going to check where the velocity is 0, because when it crosses over a point where the velocity, which is similar to speed, where that's 0, someone could start moving forwards or backwards. It can signify a change in direction. We just have to be very careful about moments where the velocity hits 0. So check when the velocity is 0. So we set 0 to be our formula, t squared take 3t. Thankfully this is a relatively easy one to factorise. It's got a t in common. So it's going to be t take 3, meaning that either the t itself equals 0, or t take away 3 equals 0, meaning t equals 3. So, therefore, velocity is 0 at t equals 0 and t equals 3. This is critical for properly answering the questions that we're about to face. So, question A says a distance travelled between t is 3 and t is 5. The good news about that particular, technically it's a domain, is that there isn't, except for precisely at t is 3, there isn't a point there where it potentially crosses the x-axis there. So, if you graph t squared take 3t, think about the intercepts are at 0 and 3, and it's a positive t squared. You're looking at something that looks like this. Between the ranges of 3 and 5, it's all positive, so we're not going to get anything weird in there. So, to cut a long story short there, the distance is simply going to be the integral of that formula between 3 and 5. T squared take 3t. So, if I integrate that, increase the power by 1, divide by the new power, increase the power by 1, divide by the new power, between 5 and 3. Nothing can be simplified there, so I'll go straight to the next step. I substitute 5 in that. 5, 3 over 3, take away 3, 5 squared over 2, and take away the whole lot if I put 3 in it. Over 2. Okay, I probably can clean that up a little bit before putting it in the calculator, but not critical. 27 divided by 3, that'll just be 9. Take away 27 on 2. So if we put that in our calculator, make sure we get our bracketing right. Whoops. 125 on 3, take 75 on 2, take away, open brackets again, 9, take away 27 over 2, close it all off. It's telling me 26 on 3, or 8.6 recurring, and distance in this case, as with most questions we are doing, is in meters. So that's our answer. It's how far it's travelled between 3 and 5 seconds.